In this lesson, we will rationalize radical expressions using conjugates. So here's the do now. Let's multiply 2x plus 3 times 2x minus 3. Well, this is a classic FOIL problem. First, outer, inner, last. The outer and the inner will cancel out, negative 6x and 6x. So you're left with a difference of squares, 4x squared minus 9. Now let's rationalize this expression. We have a denominator of radical 6. So we must multiply both the numerator and denominator by radical 6 because we want to create a perfect square of radical 36, which evaluates to 6. So the final answer is 2 radical 6 over 3 because we can reduce the fraction. Okay, so this is the leap that we're taking to rationalize the denominator with a conjugate. Now, here we have a binomial radical expression, radical 3 plus 1, which is different than when you only have the radical expression here, the monomial. So when you have a binomial like this, you must multiply by the conjugate, which is basically the identical expression, except the operation changes. Or you can think of it as the second term's sign changed from positive to negative. Whatever you multiply by the denominator, you must multiply by the numerator to keep the value of the fraction the same. So when we multiply the numerator by the conjugate, 2 times radical 3 times 2 times radical 3 minus 1, you are distributing. 2 times radical 3 minus 2 times 1 is 2 radical 3 minus 2. We'll save this for the numerator. The denominator we must FOIL. And as you can see, because of the sign change here, plus minus, the outer and the inner terms will cancel out, leaving 3 minus 1, which is 2. So putting all this together, our expression is now 2 radical 3 minus 2, all divided by 2. And you always want to check whether the coefficients and the denominator and any integers can be simplified. So here these are all 2's. We can simplify by dividing each of these by 2. And the final answer is radical 3 minus 1. When there is a binomial radical expression in the denominator of a fraction, you must rationalize the denominator by multiplying by the conjugate. The conjugate is the binomial that has the exact same first term and whose second term is the opposite sign. When you FOIL conjugates, the O and the I terms always cancel out. The difference of squares remains. Let's take a look at another example. 5 divided by 4 minus radical 13. Well, the conjugate is 4 plus radical 13. So we'll multiply both numerator and denominator. The numerator must be distributed, giving 20 plus 5 radical 13. And the denominator must be FOILed because it's a binomial times binomial. Now, I did not even bother writing the O and the I terms because I know it will cancel out. The first term gives 16, and the last terms multiply to give us negative 13. 16 minus 13 is 3, and therefore our final answer, 20 plus 5 radical 13, all over 3. 20 and 3 cannot be simplified, neither can 5 over 3. So this is our final answer. Now you may be asked to do the same method here, but with a different type of question. What is the reciprocal of radical 3 plus 1? Well, just like any other number or integer, the reciprocal is basically the multiplicative inverse. So let's make it into a fraction first. Let's put a 1 under it. Let's go ahead and invert this, giving us 1 over radical 3 plus 1. And if you left this as your final answer, you would lose points because the denominator is not rationalized. So let's go ahead and multiply by the conjugate. The numerator is easy because 1 times anything is anything. And the denominator must be FOILed. Radical 3 times radical 3 is 3. And 1 times negative 1 is negative 1. 3 minus 1 is 2. Final answer is radical 3 minus 1 over 2. Okay, here's another example where you have a rational expression, which is a binomial in the denominator, but you also have a binomial in the numerator. So we treat this the same way. You must rationalize the denominator by multiplying by radical 3 plus 5, and multiply the same by the numerator, radical 3 plus 5. And in this case, since we have a binomial times a binomial in both the numerator and denominator, we must FOIL twice. So here we FOIL the numerator. Radical 3 times radical 3 is 3. 5 times radical 3 is 5 radical 3. Outer terms, also 5 times radical 3 is 5 radical 3. When you combine like terms, you are only adding the coefficients. 5 plus 5 is 10. Keep the radical 3 the same. And the last terms, 5 times 5 is 25. Putting all this together, we end up with 10 radical 3 plus 28. Now let's FOIL the denominators. And here we know that the O and the I will cancel out because of the sign change. Radical 3 times radical 3 is 3. Negative 5 times 5 is negative 25. Putting this together, combining like terms, 3 minus 25 is negative 22. So now we have our numerator, 10 radical 3 plus 28, and our denominator, negative 22. Let's look at each of these coefficients or terms, and let's see if they can all be simplified by the same factor. And I hope you recognize that 10, 28, and negative 22 are all even numbers, so we can divide each of these numbers by 2. Half of 10 radical 3 is 5 radical 3. Half of 28 is 14, and half of negative 22 is negative 11. Notice that the negative 11, the negative sign, floated up to negate the entire fraction. Here's the last example we'll look at. Once again, it's a binomial over binomial. This one is a little more complicated because it has a coefficient in front of the radical. But don't worry, we will approach this the same way, multiplied by the conjugate, 4 plus 2 radical 3. You must be very neat and organized when working these types of problems out. There's several steps, and with these several steps, it gives room for a lot of careless mistakes. So I label this FOIL with numerator and this FOIL with denominator. Let's FOIL the numerator. As you can see, 3 times 4 is 12. The outer terms gives me 6 radical 3 because you're only allowed to multiply a number times the coefficient. The inner term is 5 radical 3 times 4, which is 20 radical 3. Combining these two terms, because they are like radicals, 6 plus 20 is 26. Keep radical 3 the same. And the last terms, 5 radical 3 times 2 radical 3 is 10, right? 5 times 2 is 10. And radical 3 times radical 3 is radical 3 times 3. Taking one of them out, we end up with 3 times 10 is 30. You can also think of this as radical 3 times 3 is radical 9, and 9 is a perfect square. Square root of 9 is 3. 3 times 10 is 30. So the numerator, after we combine like terms, is 42 plus 26 radical 3. Time to FOIL the denominator. 4 times 4 is 16. The outer and the inner terms cancel. The last term, take that negative sign with you. Negative 2 radical 3 times 2 radical 3 is negative 4 radical 3 times 3. One of the 3's comes out, and negative 4 times 3 is negative 12. 16 minus 12 is 4. So, putting the numerator and the denominator together, we end up with 42 plus 26 radical 3 all over 4. Hopefully you recognize that these are all even numbers. We can divide by 2. And after you dividing by 2, half of 42 is 21, half of 26 is 13, and half of 4 is 2. The final answer is 21 plus 13 radical 3 all over 2. Good luck to you.